lots of mayhem out there between the puddles and the people who've written to me saying their house is still wet. So we're just going to be a nice cozy group. However, I do need to still do it up on the overhead because it's filmed for these people who aren't here. I recognize lots of faces. I recognize everybody. Do you know me? I'm Carol Little, I'm the math coordinator. I'm not going to go off on my usual stump about a lot of things because I want to just get into the math here. This is the 3rd grade unit on multiplication. This is the second time the kids are seeing this. So the first unit involved multiplying by 2, 5, they touched on 10, so those common numbers. And this one, probably even 3 and 4. This one is more the 6, 7, 8, 9, introducing. But the kids have moved along. So we're going to take a look at it, and I'd like you to look at just the vocabulary on the first page. As we talk about how important it is to talk about math, we do give them this language. So factors are the numbers that are being multiplied, and the product is the answer. We encourage this use, but math is not a vocabulary test. There's probably anchor charts up on the walls that has this information. We are not trying to trick the kids, we're trying to help them. Come on up, we're going to be a small group. So yes, we've got the information or the vocabulary, but they're still using what they want to. What they discover is by having the exact words, it's actually easier to talk about. Instead of, you know that number. No, I don't know that number. Which number? We're talking about the factor and the product. Multiples. Multiples is a number that's about our skip counting. It's the 2, 4, 6, 8. 2 times 2 is 4. 2 times 3 is 6. These are all our multiples. Okay, people are showing up. I'm going to pass out some things. Good morning. We know what it's like out there. Multiple probably is not as used as much as factor and product, but it's a word they'll hear it in passing, and I wanted you to know what it is. Commutative property, this idea that you can switch the order of the factors and you get the same answer. You do not necessarily get the same story, but you get the same product. We're going to be working with that today. Again, not tested on the, I don't even know how much they talk about the language there, the commutative property, but the understanding of that is incredibly important. And in this unit, that's what we're going to start talking about first off. Divide, division, equation. We use the word equation. We also accept number sentence. The big deal about an equation is that it's balanced on either side. It means the same as. 2 times 4 is the same as 8. Parentheses. I'm American. Parentheses is the right word. I don't know what the rest of you use. No. For us, parentheses are rounded, and for me, a bracket has square edges. That's not true around the world. So we use both the words interchangeably now. I mean, I think the Americans probably use parentheses more often, but we totally accept brackets. The only way, they're quite important in this unit, but not as in the precise order of operations, which comes in 5th grade. It's more that we put parentheses about the things we're doing first. So it's a lovely introduction. You're letting me know what you're doing first, and you'll see why, because it really gets into great flexibility of thinking. Quotient's the answer to a division problem. Skip counting with an extra comma in there. Skip counting is one of the ones where you guys can be real supportive. Skip counting is the 2, 4, 6, 8, 3, 6, 9, 12. Yeah, we can do those. What can you go above that? They can do 5s, they can do 10s. Being able to do the 4s, how can they figure them out? Because skip counting is multiples, is related to multiplication. And this starts coming when we start asking them to know these at automaticity, or what we sometimes call memorization, which is not right now, but it's starting to come. The kids really have worked with 2s enough, they probably should know their 2 facts. They're doubles. So the skip counting is a way to practice that baby step to start moving towards automaticity. Yes?
Are our kids expected to by heart or remember the multiplication tables?
that's a loaded question because of how we define it. We want them to know their multiplication tables by the end of 3rd grade. We won't even really start practicing games and stuff probably until about March. We want to make sure they understand what multiplication is first. But yes, we want them to know them because when they start doing double digit, we want that fact to come easily and their brain working on the place value and the larger number. So please, now is not the time to start. Now's the time to start making sure they're understanding what these are and what the patterns are with them. But by March, you'll be seeing. I've also talked to you about some of the game sites that we have that they could start playing. Because really, they probably do understand what multiplication is equal groups. And they probably understand that. To us, multiplication and division facts, we really do mostly multiplication facts because if they understand division, they're the inverse relationship and they should be able to figure that out. Now that's a big deal. I mean, that's part of this unit. And I forgot where I was going with that.
By heart.
Right, well, and by heart, oh, they won't know all of them. How many of you can do 8 times 7 right now? 8 times 7 is actually the one, in 8 times 8 are the two that are considered, they're not the hardest, they're the ones we don't remember. We just don't use them often. So when we say by heart, we want them to know most of them or have a very quick strategy to figure out what the next one is. And we're going to talk about that with, if you know your 5s table, this is what they're going to work a lot on. If you know 5 times 3, you can figure out 8 times 3. So it's 5 times 3 and 3 times 3. So we've broken it down into these smaller ones that they tend to know. So that's part of today's lesson. We're going to look at how the kids, we start helping them break them apart so they have a way to do it. So 8 times 8 is 8 times 5 and 3 times 5, and I can do both of those. And we build it and we break them apart so they don't say, well, which number am I doing it with? If they can picture it, they can figure it out. They're going to memorize most of them, especially with this understanding of the commutative property. And this is why I am very much against, you might see it, you don't memorize the 2s, and then the 3s, and then the 4s, and then the 5s. First of all, you do 2 5s and 10s first, because they're the easiest for us. And then you can go to 4s, because that's double of 2s. So there's a very distinct order that we can do that in. But if you know 2 times 8, and we've taught this unit well, you know 8 times 2. So it's not like each new factor is a whole new set, and that's what we really want the kids to understand. So these are all related, and there's not nearly as much to learn. I saw an article that said if you know your facts up to 5 times 5, there's only 12 new ones to learn. You would not imagine the joy on kids' faces when they find out there's only 12 more to learn, because they think there's 50 more to learn. So these are what we'll be setting up today. And I know what I was going to go back to. We consider the facts up to 10 times 10. I know in the US it used to be up to the 12s. Really, there's a strategy for finding those. So when we talk about the automaticity, we're really talking up to the 9s because everybody can do the 10s. We go ahead and do the 11s because it's so easy, you have to mention it once and the kids understand it. But math facts are considered up to 10 times 10. Unknown. This is where the kids start feeling very mature that they're doing algebra. We do start using a letter instead of a question mark or a blank line. We talk about how to choose a letter, and it's usually within the context of the story. But we talk about in algebra, it's usually N or X, Y, and Z. I don't know whether they usually use Z that much, but X or Y. And then I wanted to reintroduce the array is really how we're showing our groups now. Instead of circles with all these things in it, we are using this organized pattern. They've been building arrays in addition. They used arrays with the multiplication in the first unit. And by now, this is really what we're expecting. If you're showing me a story of 8 times 4, I would expect to see it in rows and columns. And the tape diagram. You guys all know my love affair with the tape diagram. This is for the word problems that shows us that they understand what the word problems are asking us. So let's get started. Recognize this? Okay, the multiplication chart. We are filling it out, and this is where I want to show you where the patterns come in and what the kids do know already. So I kind of like well, I want to show you something first. I just mentioned the arrays. When a child can see an array, they can see what the value is. Find two blank pieces of paper. If I look at 4 times 3 on this chart, I have the array. So I'm looking at 3 times 4. Here are the 3 rows of 4. The array is right there. If a child needed to, they could now skip count up. It's like 4, 8, 12. So I have 12. If I have 7 times 6, I do have my 6 rows with 7 columns. So this actually does help them figure out what it is. It's not just a memorization chart. I didn't know that until about 10 years ago. I thought I had to memorize it or follow the patterns, where it has given us a way to solve it by using the arrays that we recognize. Can I ask you just to join one of the other tables just because we're going to need stuff?
Yeah.
So if we take a look at this, we read it across. 1 times 1 is 1. 2 times 1 is 2. 3, 4, 5, 6, 7, 8, 9, 10. If I know 1 times 10, I know 10 times 1s. Except I should be saying this. I know 10 times 1. If I know 2 times 7 is 14, I know that 7 times 2 is 14. I would like you to figure this, I would like you to solve this, but I would like you to do it in those partners. If you do 3 times 4, I would then like you to do 4 times 3. Start seeing that relationship of the commutative property. You know, I'm going to be even stricter than that, but you do the 2's first. Do 2 times 2, 2 times 3, 2 times 4. You can either go down first or across first. So I'm going to do it the down, so I'm going to do 2 times 3 is 6. So I now know, if I know 2 times 3, I know 3 times 2 is 6. If I know 2 times 4, I know 4 times 2, which is filled in for us. I know 5 times 2 is 10. I know 2 times 5 is 10. I know 2 times 6 is 12. I know 2 times 6, I said the same thing, 6 times 2 is 12. So what you start seeing is the pattern goes down and then it goes across.
Is it okay? Because my first thing was to think, okay, this I count by 2, by 3, by 4, by 5. If I
Yeah, that's the skip counting.
Yeah, if I tell her that it's okay?
Yeah, but I might then ask, so how does that help you? Because I do want them to know that it's 3 5s is 15. So I honestly would rather, my gut reaction is I'd rather have them saying 3 times 5 is 15, 4 times 5 is 20. What do you notice? Oh, it's the skip counting.
Okay.
But I really want that relationship to the multiplication. Because just being able to skip count, we still have to apply it to how many times have we skip counted. But can they still use it to get the answer? Absolutely. So let's move on. We know we can do this, but I will show you. This is the area that will be the new learning. I've got 9 squares. They probably included that. The these are the area that will be particularly new to them. These are the areas that most of us have one or two problems that we still figure out. I always pause at 8 times 7 until a child told me, but it's 5, 6, 7, 8. It's like, 7 times 8 is 56. I can do that because I never knew it was 56 or 64. So we do get to those little tricks, but those are later. They'll start showing them the 9s. They'll start showing it the relationships of the arithmetic patterns. So your child should or is welcome to use this chart at any time. But we do move on and start looking at these arrays. And this is just simply problems that have them thinking this through. So we have 4 rows of 6, and that equals 24. We can write it both ways. And I believe the author purposely wrote it as 24 equals what? Because we've got to get used to that equal sign being able to move around. It doesn't matter if the product comes first or the factors. It's still a balanced statement. Right? Yeah.
For Gr3, is it preferable to write 4 by 6? Because I remember me when my over one ratio of 6 by 4 and the ratio.
You know, the truth is, if I knew the child understands both of them, and it's just something like this, they're both correct. What happens in class is we get started, we want them to say 4 groups of 6. So I'm saying 4 groups of 6. But this lesson is about understanding that that works the same way. What's going to happen in class is the teacher may ask them to write in a certain way because of the lesson, but by the assessment, we're not going to care. What happens is because we want to have this discussion in class, it can get quite confusing if we're not all saying it the same way. I know in 5th grade, I would just flat out tell that to them, we're going to talk about the rows first and the columns second, just so that we can have that agreed upon conversation, so that we're all picturing the same thing, not because the math is different. And we're early in the unit, so I could see why a teacher's saying that. Now, it will make a difference. There are times when it comes to a story problem where I'm like, 4 groups of 6 flowers is different than 6 groups of 4 flowers. So in context, I got a different answer. Okay, so this next one is the same one. I managed to somehow pull 2 pictures equal to 24, which then I kind of liked because we can see that different combinations of factors can have produced the same product. As I mentioned earlier, these next 2 problems are just about the idea that we're not using a blank space or a question mark, and the idea that the letter is the value, and they will be asked to start writing their equations using letters. So Z would equal 45, V would equal 5. If they didn't know those, they would be welcome to go back and use the chart, or use an array, or use whatever method they want to play the answer. This was more to introduce to you the idea of the letter. Yes, absolutely. This is, yep.
The meaning of group, the meaning of the word group means horizontal, not vertical. Right? This is how we are using it now. That 4 groups of 6, not 6 groups of 4.
And I would. Yeah. That's how I see it. I'm not going to. Well, group's not going to be hard. That's rows and columns. Is probably what they're going to be talking about. This is there's 4 rows. I would say 4 rows of 6 groups. I don't know that I'd probably try to get away from the word group with this. There's 4 rows and 6 in each row. Probably what I would say. Again, some of this language is so that we can have the discussion. It's not a mathematical definition. There's not a mathematical definition. So back to all this computation. That's what arithmetic and multiplication is so that we can solve real life problems. So we're going to look at this. Pedro buys 4 books at the fair for $7 each. What is the total amount Pedro spends on 4 books? Use the letter B to represent the total amount Pedro spends, and then solve the problem. So I want to see what the picture is. Pedro says the same amount on 4 books. So this is my tape diagram representing my books. Here it is. He spends $7 on each. At this point, the kids are probably going to write 7 in each. That's not going to last long because the numbers are going to get too big, and I'm not going to expect them to do that at the beginning. I want kids to understand these are equal groups. And then the question is, how much money does he spend? I've been putting a question mark up there. Now I'm going to put the letter B. The equation is 7 times 4 equals B. I don't see any reason. Is there any reason why 4 times 7 isn't just as good? I think it all depends on how the child is thinking about it. So we do want to honor that, because as soon as we say only one way is right in this context, well, one, we're wrong, because both of them are right. And if a child is seeing it the other way, that is going to be very confusing. And then B equals $28. We'd expect the dollar sign. There's context to the story. It is $28. And I honestly would make them still write out that answer statement. Pedro spent $28 on books. And this is where we've taken a story, we put it into the math language, and we've taken the answer and we put it back to the story. And it is a way of double checking that they're actually answering the question that was answered, or the question that was asked.
Would it be okay if the kid writes B is equal to 7 plus 7 plus 7 plus 7?
Are we talking up here?
Yeah. The
Okay.
equation. If the
Yeah.
equation
The
is
reason it's accurate. What we do, and I'm not sure if you've noticed this at the top of assessments, is we have I can statements, and in 3rd grade it says I can multiply. If a child writes B equals 7 plus 7 plus 7 plus 7, it's accurate, but they've shown me nothing about multiplication. So if I were to see that in class, that I know where to start helping that child to nudge them on to the next step. So we do, I do understand that multiplication is repeated addition, but that we are trying to get them to move on to multiplication. So we would talk about the efficiency. We're talking about what are we really learning. Now, if they showed me both, great, they're just showing it to me. Kids really, many kids are teacher pleasers, and they are trying to second guess what they think we want. So we want to, if that's the child writing us 3 different ways of doing it, great. If it adds dimension to their answer, I'll tell them that. If others, I'm going to say, that's great that you understand that. And I can tell that by this statement here. Because I don't want to waste their time. I don't want them just writing things down to hopefully please somebody else. I want them to write it down because it makes the math more meaningful.
right. So ideally you would like to see a multiplication equation.
Yeah. Now, we're still very early in the 3rd grade year. Yes, I'm just going to, that's what we're learning. We're learning multiplication. But we do go into 2-part questions. So Pedro hands the cashier 3 $10 bills. How much change will he receive? We are talking about the question right before. This is a story. Write an equation to solve. Use the letter C to represent the unknown. So we know, well, we have the books were $28. I'm not sure whether I would need to see this or not. In this case, so this is 30. Now, do you notice I wrote the question above it and then I wrote it below it? That was simply because how I drew my picture. They're still part whole representations. So we've got $30. So I need $30 minus $28 equals C. That's the equation. And honestly, there probably wouldn't be the dollar mark there for the equation. 30 minus 28 equals $2. So Pedro will receive $2 in change. Does this all make sense? So what I'm doing is I'm following the order of the lessons your kids are receiving. So it's not like we're going to do only math facts and then only word problems. They get mixed along the way as they keep growing. Also, just a reminder, your kids have not seen all this yet. Please do not go home and try to teach them this entire packet tonight. They're not ready for it, and you're getting a 50-minute version and they're getting a 6-week version. So we do a lot with multiplication and division, then we really want to make sure they start seeing that related facts and how they are together. So can they understand a story? Mr. Strand waters his rose bushes for a total of 15 minutes. He waters each rose bush for 3 minutes. How many rose bushes does Mr. Strand water? Represent the problem using multiplication and division sentences and a letter for the unknown. Then solve the problem. I'm going to use n for the n unknown. So if I used a multiplication problem, I have 3 times something equals 15. So that would be where my n goes. Or I have 15 minutes divided by the number of minutes, or 3 minutes, and I would get how many rose bushes. I need to tell you what the n stands for. So the n stands for rose bushes. And if a child didn't know it, you can come back here. He watered for a total of 15 minutes. He waters each bush for 3 minutes. How many bushes will there be? And sometimes they put the 3 dots in there. We don't know what the answer is. We know that's what we're solving for. So being able to take a real life situation and think of it as multiplication or division is really important, because kids are going to see it different ways. And if I walk up and tell a child this is a multiplication problem, actually we probably walk up and say this is a division problem, and a child is thinking in my head, but it's blank times, I'm going to get my numbers wrong, it's 3 times blank equals 15. A child who's struggling is going to shut down. They're like, okay, now she's telling me it's division, but I thought it was multiplication. The fact is we were both right. So we don't talk about them as being one type of problem. We do discuss how they can be solved both ways. Some kids may never see it both ways, but we're giving them the opportunity to learn both. Most of them will learn both ways, but they'll have a favorite way of doing it. Many students will never say in their math facts 81 divided by 9 equals blank. They'll say 9 times what equals 81. Perfectly sound strategy.
Karen,
Yep.
for a problem like this, the one that you did, would you require them to show how they got the answer in, or if they would just, and I'm assuming if they know and it's 5, if you just write down n equals 5, is that acceptable, or do you need the tape diagram for that?
To me, this is kind of that. No, I don't think you need the tape diagram here, but I know what the point of the lesson is. On the test, they're not going to have something nearly. How do I say that? It's not that it's this simple.
Right, I mean, if it's a bigger number where they
To me, this is a very straightforward problem. So you don't need if you don't need the picture, you shouldn't have to draw it. When we want the picture, we call it problem solving, where they're not straightforward, where you can't just see it. I mean, I would say this one was more of a problem solving, except that we split it up into 2 parts, which immediately made it kind of 2 simpler problems. These, in our world, would be called word problems. All we've done is taken a fairly straightforward arithmetic problem and given it context. The difference, and you guys don't need to know this, but the difference between problem solving and word problems is there's ambiguity in problem solving. There's lots of ways of solving it. You can't just look at the numbers and grab them and multiply. You have to think about what's going on and make your decisions.
In word problems, I usually have problem with my son. So when he reads it, I read it out to him. Or if he reads it, he would directly give me the answer 5, whatever. Yeah, 5 for this word problem. But when I would ask him how did he get it, he would be like, I don't know. He would just prompt the answer, and when I ask him how did he get it, he'd be like, I don't know. I just
Okay, and
in
I'm
my
gonna,
mind. That's
yeah.
what he would say.
I had a gentleman here last year who kind of saved me. He goes, if I went into my boss and said, I don't know, I just got it, I would be fired. So I know at some point on these really simple ones, they do kind of just know it because they've internalized the information or the fact so easily. I mean, I'm not asking anybody to show me 5 groups of 3 here in an array. It's just that we go quickly from using the computation into problems where we need to see their thinking. We call it make your thinking visible. On a 3 times 5, I'm not going to ask that. I mean, on this problem, this would have been absolutely required. I did this with a child who may not know what was going on. And if a child said 3 times 5 is 15, and I said explain your thinking, I would accept the answer known math fact.
So I'll actually have to work with him to.
And again, on the 3 times 5, if they know it, we're not trying to move them backwards. We're not trying to make them draw things out that they already know. But if we don't know where that information came from, that's when we need to know it. So math facts are one of those ones. I would accept math fact. And I'm going to be glad. They know it, they're moving on, they're ready to move that, they're ready to use that knowledge to move on to something harder or more complex. On any given day in class, the teachers might ask for a little bit more because they're still learning where the kids are at that point. And we don't give math facts tests. I don't know who knows them. I mean, I have a general idea usually because you can tell. So on a piece of practice work, the teacher may ask for it. On the assessments, if they're explaining their thinking and we can see where it comes from, it's not about the math fact.
Where did we solve that problem?
Did we never solve the problem? Did it ask me to? So this would now be n equals 5. Pardon me? Yes. Yeah, and I wouldn't expect. No, I would not expect a drawing of 3 groups of 5 or anything. This one shows that you understood. Honestly, I think this would be a pretty tough question for a lot of kids to begin with. And that's why this picture might be done. Because if they're going to see it one way easily, it's whether they can see it the other way. And we want them to see that relationship. So I mentioned at the beginning that 12 is not a math fact for us. So we get into how can we break large problems apart? How can we decompose them so we do have access to them? So I could look at this, and 3 times 12 I know is 36. How can I prove that? Well, I can break it into groups of 3 times 3. So I have 3 times 3. How many times do I have that? I have it 4 times. So that means I have 9 times 4. Now we're to a math fact that I know, and the answer would be 36. 3 times 10 and 2 times 3. Look at that, right there. That's when we break it. You're just about 2 minutes ahead of me. Yes, you can break it into 10 and 2.
Because for me, when there is 10,
Yes.
it's a little easier than 9 times
Yes.
4, I think.
Absolutely. Absolutely. I think that the commonplace one would be to break it into 10 and 2, but we're showing them that there's lots and lots. And part of this is also, this is going to help the kids with the 8 times 8 so that they can visualize it and there's no 10 there. So I think that's probably why they did that. This could have also been broken into, these 2 groups. So if you just look, would you do, they're walking you through that in the next problems. So you can see 3 times 16. Now 3 times 16, if you read the 3rd grade standard, sounds like it's above and beyond. This is where we're stretching the kids. But we're giving them the strategy that's within the grade level. So talk about our standards being the bottom floor. This is how we can stretch kids who are, this is finding it pretty easy. But what we don't really want them doing, we want them to have the flexibility that they're not doing 16 times 3, 3 times, I'm going to get my numbers wrong, 16. So we're giving them a strategy to break it apart so they can do it with mental math. So this one can be, we know that 16 breaks out to 2 times 8, so I can multiply the 3 times the 2 and get 6. 6 times 8 is 48. I could do, well, it's the same thing. I could do 3 times 8 is 24, and it's double, 48. So all those ways of breaking things apart.
Will it be okay for them to break down 16 in 10 and 6
Yeah.
and multiply 3 times
Yes. Yeah. I mean, I know the reasoning why the book did this one first, or our resource did this one first, is to help them with smaller numbers. On the next page that we get to, you're going to see that we're going to get to the breaking it down to 10. Yes, I would agree. I would do it to 10 and 6.
Because I don't know, for me, I thought it was just easier than doing this.
Yes, it is. Some, yeah, not that we like to make things difficult. Sometimes you can understand the patterns better. Sometimes at the 10 times, it's so in my head I can't explain it. Where we break it into these numbers and they have to think about what we're doing. And I'm going to look at the time, so I'm going to keep going. Those I gave you practice problems. Yeah. So this somewhat answers, we're telling the kids to draw a model on here, so we're expecting it. Ms. Sampler divides 32 students into 8 equal groups for a field trip. Draw a tape diagram, label the number of students in each group as n, and write an equation and solve. So we have our whole is 32 kids, 8 equal groups. And label the number of students. I don't know how many are in the group yet. And this is where I would not require a child to do this, but at the very beginning, your child's teacher might. So just if they're struggling to understand what this means. So what does this mean? To me, this is 32 divided by 8 is going to give me n. And I'm in front of you and it's being videotaped and I'm quickly going in my head, does 4 times 8 equal 32? Yes, good, I did it correctly. We will be nudging kids to do that double check, not all kids probably, but this is where we talk about the differentiation. Are these kids seeing that, again, that relationship that they double check their work? The next 2 are similar problems. The next one's a multiplication. I shouldn't say that. I think actually it has to be multiplication. And then the next one is that 2-part where they compare the information. But I want to move on because of your questions. Actually, I do want to do 4 because this is again back to the modeling. Julio spends 29 minutes doing his spelling homework. He then completes each math problem in 4 minutes. There are 7 math problems. How many minutes does Julio spend in his work at all? I thought it was 20. So what would we do? We would do, he does 29 minutes. He does 7 math problems at 4 minutes each. And on this problem, I would make them label all of it because there's other information on the tape diagram because of that 29. Now I need to label this. This is spelling. This is math. How many does he do in all? I'm going to put H for homework. It doesn't tell me that I have to, but I'm a 3rd grader. I've been learning it and I want to use my new skills. So So 29 plus 4 times 7 equals h. If they choose to write this, they are going to have to put the parentheses in. This is the lesson that they will be learning. I'm doing this group together, so that's why parentheses go around it. That is as technical as we get. Because we know that 29 plus 4, quantity 29 plus 4 times 7 is a very different answer. We don't go into that a lot with them. Now it's just tell me what you're doing. Oh, you're multiplying 4 times 7 and put the parentheses around it. So it's 29 plus 28. I don't know how kids are going to do this. I would do 30 plus 30 equals 60 minus 3 equals 57. How do I get this answer? I'm probably expecting to see some sort of work, visible thinking from the kids. Because at third grade, that's not that it's a hard problem, but they don't just know it. It is not a math fact.
In experience, when kids at this age don't get confused with the parentheses, meaning like they will try to multiply 4 times to add 4 plus 29 and then multiply by 7.
But we go back to, but what are you doing?
But do they no?
No, it's kind of amazing. When you talk to them about what they are actually doing, they completely understand it. They're saying them in their number talks, and we're not, as I said, we're not complicating it and talking about, it usually gets into the order of operations. It's just, what are you going to do? Are you adding the 29 and the 4, or are you multiplying the 4 and the 7? I'm multiplying the 4 and the 7, and they write it. I mean, the bigger problem is kids who just forget to write it. They don't tend to write it wrong. So then my question would come back to, well, I don't know what you're doing first here. Tell me what you're doing first. Oh, okay. Finding the terms. As they move into the unit, we don't want the kids to start multiplying and using, how do I say this? Explaining things incorrectly. But like when you multiply by a 10, you don't just add a 0. Adding a 0 gets you the exact same numbers. 3 times 10 is not 3 plus 0. What they're trying to tell you is you're multiplying 3 10s, and so that would be 30. Now that is the same as 3 times one group of 10. Well, okay, that's 3 groups of 10. I know 3 groups of 10 is 30. So it's not, we're not changing the answer, but we are giving them that language to explain what they're doing. And that's what this shows. You'll be seeing some of this work come home. I know 2 times 4 ones is 8, so 2 times 4 equals 8. Well, I know that 2 times 4 tens is 8 tens. So 2 times 40, that's an 8, equals 80. So by using the language or the word tens, the 0 disappears. It's not about that, but I can translate it back rather easily. I don't need to count zeros. I don't need to add zeros. I know I'm talking about the place value of the tens. Next year they'll go 2 times 400. 2 times 4 hundreds would be 8 hundreds, so you just write 800. So we get away from this idea of memorizing tricks about zeros. And the last two. So actually, I thought that was going to be the breaking up of tens. It's on the next page. So now we're into the tens, but we've also, we're breaking it into multiplying by 10. And this is the highest end of the multiplication they do, is being able to multiply a single digit times multiples of tens. In English, that means 2 times 40, or 6 times 80. And we're going back to that idea. Am I flexible? I can think about, let me do, what is the first one? 2 times 20. Well, I can break apart the 20 into 2 times 10. 2 times 2 is 4. It's 4 tens, so it's 40. The biggest change in our teaching with Common Core is that flexibility of breaking numbers apart so that we can handle them. We have the knowledge, but before I was told it was a rule and I needed to take out a piece of paper and I needed to write it in direct columns. In fact, I turned my paper this way so I had lines so I could write it in direct columns. I was never shown that it's perfectly efficient to be able to take the numbers apart and regroup them back together to make it easy for me. So 2 times 30, well, okay, that's 3 times 10. I know 2 times 3 is 6, times 10 is 60. This is where kids are also going to see the numbers differently. I'm not sure they can see these much differently. So, but it's giving them the permission to start figuring these out without using a standard algorithm. And one of the problems, somebody, I really need to look this up. Somebody told me that once your brain sees the algorithm, it doesn't like to go backwards to other strategies. And I kind of said, fine, that might be true. I didn't see the study. The 3rd grade teachers are coming to me right now, in addition, and saying they're absolutely doing nothing but using columns and the ones, tens, thousands chart to add and subtract. When it's like 101 plus 40. They're writing it down and putting it in columns. 101 plus 40 should be mental math in 3rd grade. They can take the 1 away if they want for a minute, but 100 plus 40 is 140, plus 1 more is 141. So we want to get away from that paper and pencil is the best solution, and I think they think it's the smartest. I think they think that's what they see their older brothers and sisters doing, and that's the way they ought to be doing it. So we're kind of not fighting a battle, we're joining in them to see that there's lots and lots of ways of solving these, and the efficient way often is the mental math way. So we give them these different strategies to try. We know that every single child is not going to like the same strategy. We know that different kids are going to have favorites, but we will also push them to practice ones that are not their favorites. Because if we don't practice it, they may never get to that point of realizing, oh, that one actually does work better for me. And there's quite a lot of strategies that are used at different times, depending on what the question is or where you are. So, the biggest idea is decomposing numbers to make them work for you. So that's what this last group is about. I misspoke earlier when you said you wanted to break apart 16 into 10 and 6. I forgot. I thought that was going to be this. So yes, I do think on the larger numbers you would probably break it down by place value, and that is actually the beauty of our number system, is how well it does break down into 10s and 1s. So I put 2 problems that come from this resource, and in reading them, they might look tricky. However, if the kids understand what they're doing and can draw the picture, the story, they can figure these out. It says, Brad receives 5 cents for each can or bottle he recycles. How many cents does Brad earn if he recycles 48 cans and 32 bottles? Standard says single-digit multiplication. But by the end of the unit, the kids should have several strategies of doing this. And I'm going to cheat and show you how I did it earlier today. I'm going to show you 2 different strategies. And we give the kids more room. I didn't really much. So the red was one way of doing it. I broke apart 48 into 40 and 8, and the 32 into 30 and 2. I know how to multiply 40 times 5 because it's 4 times 5, and then multiplied by 10. And then I needed to add the 5 times 8, and I got my 240. Does everybody follow how we got here? All of that was done at a 3rd grade level skill. Oh, big enough? Then I did the same thing for the 32. 30 times 5, 3 times 5 times 10, 15 times 10, 2 times 5, and I get 160. I added the two amounts together, I got 400 cents or $4, both are perfectly good solutions. Then switch to my blue pen. This was written purposely for third graders. It added up, 48 and 32 adds up to a multiple of 10. So I could have added the cans and the bottles together, I would have gotten 80. Well, that's 5 times 80. I know how to do 5 times 8 times 10. And I get the same answer.
Oh no.
So all of a sudden, what looks like a much more difficult problem, the kids have practiced strategies, at least 2 different ways of solving this.
No, I don't do that.
And that's as by far as how challenging they get in third grade. The other thing that we can do is we move on to, I would say, a more complex story, but not that the arithmetic is more complex. But if I can get to the picture, then I've got lots of ways of trying to figure this out. This will be up on the live parent math resources binder today. The video will take a couple days and it will have all the answers on it. I would like to talk to you about the last page. I see people copying this down. The last page are websites. There's nothing new to them. Math Playground has logic games. If your child is acing this, there's still a lot else they can do to be practicing math. Math Cats, Hoodamats, Math Activities are all just good sites. The one that I put down, let me just do this. What I want you to look at is this site right here. If you want your children or your child practicing math facts, that's fine, it's about time. We're not asking you to do it yet, but if your child's enjoying it. I see why I did it that way. This is called, I have to come up with the right name. Let me give you the right name for it. This website is for you to be able to check any, get the proper name, it's like common, it's a website that you can go to that you can check anything you want to see if it's child appropriate. It tells you what the site is about. It tells you if it has, Common Sense Media is the name of it, which is what I should have written down there. It's commonsensemedia.com. It is not a math site, it's a review site for movies, for TV, for books, for anything. It's commonsensemedia.com. It's an excellent, excellent site, and it will filter things. So I went up there to look for math facts games. The first one came up 4 stars, told me it cost $1.99. I went down to the next one because I believe in free sites. The next one came up with a review of many, many, many ads. So it only got 2 stars. For a third grader, I would probably care that it has all those ads. If it was an older child, I may not care, so I might be willing. So they give you the reason why it's getting the stars. The proliferation of sites is I cannot possibly keep up with them. So that is the best thing to use all the time, for, as I said, for your books, for your TV. But you can write in there multiplication fact games. You can write in anything you want and it will narrow it down. There were 109. It's not reasonable for me to sit there and go through the 109 and tell you which one is the best. Plus, kids react to the games differently. Some of them like I mean, there's the arcade type games where it's beat 'em up, blast 'em up, and they'll tell you, uses guns. If you're against that, then you don't choose that one. Some of them are fishing, a little fish go by, that might be better. And kids do react to them differently. So instead of me handing you one or two sites, I'm giving you the knowledge of how to find it out and let your child look at them. And that way you can decide. The ads I know is a big deal. I would probably still open a site that has ads and take a look at it. But it depends how invasive the ads are. On the last page, there's a review of today. And then I'm going to tell you, if you see the red printing on the back, those were the two I meant to cut off, and they just printed on the back. If you wanted to copy them, these were just two more problems. So, any questions? Yes.
It's okay to use the paper and pencil while practicing the website.
Sure. And at the beginning, I would have that multiplication chart there. Yeah, absolutely. You know what? The way memorization.
Like,